To wrap up the section here, we're going to consider something called the empirical rule. So the empirical rule only refers to mound-shaped or bell-shaped data. So this is the distribution of the data, relative frequency, histogram, but given as a continuous line instead of bars. If that is the case, then if you have symmetric or mound-shaped distribution, your mean, mu, is going to be in the center. That'll correspond to a z-score of 0. And then if you add one standard deviation, you'll be at the mean plus sigma. Remember, standard deviation is sigma. And if you subtract one standard deviation, you'll be at the x-value mean minus sigma. So the mean plus one standard deviation means one standard deviation above the mean. That's a z-score of 1. X minus sigma, one standard deviation below the mean. That's a z-score of -1. And similarly, if you add 2 standard deviations, you're at mean plus 2 sigma, which is a z-score of 2. If you subtract 2 standard deviations, you're at mean minus 2 sigma, z-score of -2. And the same thing with adding 3 standard deviations or subtracting 3 standard deviations. And then these percentages are the percentages of data that are in each region of the distribution here. So from the mean up to 1 standard deviation above the mean is 34% of the data. Between 1 below and 1 above in standard deviations, 68% of the data. From 2 standard deviations below to 2 standard deviations above, 95% of the data. From 3 standard deviations below to 3 above, 99.7% of the data. The 13.5% here, for example, that's between 1 standard deviation above and 1 standard deviation below. And the 2.35% between 2 standard deviations above and 3 standard deviations above. And then there's a little bit of data out here, so that if you just go to the right of the mean plus 2 standard deviations, that's actually 2.5% of the data. So there's 0.15% down here. And same on the other side. If you're strictly less than 2 standard deviations below, that's 2.5% of the data. So now we can answer questions here using this distribution. So the mean score on the GRE is 500. So your mu is equal to 500 with a standard deviation of 100. So sigma is equal to 100. If the distribution is mound shaped, that means we can use empirical rule. What proportion of the students scored between 300 and 700, greater than 600, and more than 1 standard deviation from the mean? So to solve these, what we can do is we can sketch our mound-shaped curve. So for part A here, let's sketch our mound-shaped curve over here. So our mean in the middle here is the 500. And our standard deviation is a 100, so we're going to add that 1, 2, 3 times, mark those cutoffs. So 600, 700, 800. And we will also subtract it 3 times, 400, 300, 200. So first they ask us between 300 and 700. So that's between here and here. So that's 2 standard deviations below to 2 above. So 2 below to 2 above. And if we scroll up here, that is 95% of the data. So A is 95%. And they are asking us, what proportion? So 95%. Greater than 600, part B. So greater than 600 is to the right of 600. That's one standard deviation above, so that's this area in here and this area to the right. So that's going to be this 13.5% plus the 2.5%. So this would be 13.5 plus 2.5, which is 16%. So 16% of the people that took it should have scored higher than 600. More than one standard deviation from the mean. So more than one standard deviation from the mean. This is exactly one standard deviation from the mean. The data over here is more than one standard deviation from the mean on the right. 400 is one standard deviation below. This is more than one standard deviation from the mean on the left. So we actually want this area here plus this area here. Well, in part B, we found this area was 16%. It's a symmetric distribution, so this over here is also 16%. So part C is going to be 16% plus 16%. So you're going to double that, 32%. So 32% of the test takers should have scored more than one standard deviation from the mean. So the key is to put your mean in the middle of your distribution, add standard deviation 3 times, subtract 3 times, and then mark off the cutoffs for the area that you want, and then go up here and see what the corresponding percentages are. So you're always referring back to this diagram when you're doing empirical distribution.